Alrighty guys, welcome to day 10 of Advent to Code. Here's hoping this one goes well. I will note tomorrow's I might not be on time, I might be doing it later. I have a Christmas party to go to, so just be notes that tomorrow's might not come out at the kind of 1 a.m. midnight time, but I will be still doing it anyways. But anyways, let's get into day 10 here, see what we got. You guys summary and determine the best route out of the deep sea cave, but only will apply syntax error in navigation subsystem online, all of them. Alright. Damage works a thought to bring up a copy of the navigation system puzzle inputs. Navigation subsystem is made up of several lines containing chunks. There are more than one chunk in each line. Each chunk contains 0 or more other chunks. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, can immediately start. Every chunk must open and close with one of the 4 legal pairs of matching characters. Okay, so yeah, okay. So as a legal chunk that contains no other chunks, it is, as is that, more complex. The valid chunks include that. Okay, and even, yep. Some lines are incomplete, but others are corrupted. Find and discard the corrupted lines first. A corrupted line, yeah, doesn't, with a wrong, yep, okay. Okay, yeah, that makes sense. Stop at the first incorrect closing character on each corrupted line. Did you know that the syntax checkers actually have contests so you can get the highest score for syntax errors on the file? That is true. To calculate the syntax error score for a line, take the first illegal character on the line and look up in the following table. The above example, an illegal was found twice, is 3 points. Okay. What's the syntax error? Okay. This one is actually not too bad. So let's get to the code here, dump this into our inputs. So this actually relies upon just building a queue system, essentially. So what we're going to do is we're going to, I do need, we'll do this math kind of hard-coded in a sense. So we just need to find the first place. Okay. So what we're going to do is we're going to do a list here of characters. And this is going to be just our, I'm going to call it a queue. It's easy enough, just call it that. Alright, and then we're going to go, whoops, not there. Now we're going to go through all of our strings, S and inputs. The Q should actually be internal to here. Okay, and then what we're going to do is then we're going to go for all of the characters, so char C and S dot to char array. We're going to go through and basically Q, DQ stuff as needed. So what we're going to do is we're going to check here if C, actually, let's do a switch. Let's do a switch on what C is. So if the C is going to be this one, right? So this is this. Okay, so let's start with this one. If it is this, what we're going to do is we'll just do Q add on this character. Let's just add on C, sure. Actually, if it's the case of any of these, if it's any of the open ones, we go ahead and we just add on. There's 4, right? Yeah. So add on. Oh my goodness, can't alt tab correctly. Go ahead and add it on nice and easy, because again, the opening ones you don't care about, it's the closing ones. So let's go ahead and start the closing ones. So if we get this is our closing one, what we have to do is we have to grab the end of it. So we have to do char end is going to equal Q remove, and what we're going to remove is the last index. So it's going to be Q size minus 1, and we're going to do check is if the end equals the beginning, we're good. If it doesn't equal, this is where we care about. So this is where we get now an illegal character, and now we can just do some logic with the score here, I guess. I forgot a break statement up here, so let me add that real quick. Duplicate labels, okay. So in this case, so we do need a score variable. So let's make it long. Okay. So in this case, our score is going to be plus equals 3 points. And this is actually it. Then we're just gonna break. This is gonna break out of the switch. We don't return. So let's go ahead. And let's just make a exit boolean here. And in this case, we'll do exit equals true, and then we'll go ahead and happen is do a check here after the switch. If we are to exit, let's go ahead and break out of this for loop. This will break it, so we'll go to the next one and we'll continue on the process with the next input. So there we go. So there is for that one. Next up is this closing one. If it is not equal to that one, what we should be doing though, let's just do this actually. We can shorten up this. It doesn't like the chars in the switch statement here, so it's going to shorten it up by doing that. This one is 57 points. Go ahead and do that, and this is good. And then this one is now checking for this character. This character is this many points. And then last but not least, this one wants to check for that, while also having to check for that. And this one is this many points. And if we go ahead and run this now, we should be able to do a lap of our score. Let's see if we got this right or not. Okay. Hey, first try, let's go. Doing good this time. We're off to a good start. Part 2. Now discard the corrupted lines. The remaining lines are incomplete. The incomplete lines don't have any correct characters. Instead, they're missing some closing characters at the end of the line. To repair the navigation subsystem, you need to just figure out the sequence of closing characters that complete all open chunks. Okay. So hold on. Before I keep reading, let's just start with going through this. So we're going to reverse this. That way we can remove them as we get to them, because part 1 is just checking for the ones that are valid. So for int I equals input dot size minus 1, while I is greater than or equal to 0, I minus put get I. And we want to go ahead, and if we get an exit, we can also go ahead and just do input, oh my goodness, remove I. This will set us up then for part 2 here, which is just dealing with the nice ones. So there we go. So now we have just the ones that are valid, or the incomplete. To repair the navigation system, you need to figure out the sequence of closing characters that completes all open chunks in the line. You can only close, or you can only use closing characters that you must add them in the correct order so that they so that the only legal pairs are formed at all the chunks and close. Okay, completed by that. These also have contests. Okay, so it's gonna be the exact same thing. Okay, so 5 lines, total score as follows. Autocomplete tools are an odd bunch. The winner is found by sorting all the scores and taking the middle score. There'll always be a number of, okay, so good to know. So what part 2 is going to need, we're going to need a list here of longs. This is going to be the scores. And like before, we are also going to, let's just copy this. I'm lazy. Leave that. So we're going to do the exact same thing with queuing, but what's going to happen is there's going to be no exit. So we're just going, because we know these are valid, we can just go ahead and remove. We don't need to worry about checking that it's valid. So we can actually get away with doing this, again, because we know it's right, we know it's valid. What's going to happen then is all of this is going to go away, and we're going to be left with no exit logic, just going until it ends. Then when it ends, we're going to have characters left in our queue. So what we're going to have to go and do is we're going to go through char C in our queue, and we're going to have to do the reverse. We're going to have to pull out the ones in the queue and from back to front, which actually makes it a good point of, we need to do this, int I equals q dot size. This should be j, not I, because we need to go reverse, because again, to close it out, we need to start at the end of it and go that way. While j is greater than or equal to 0, j plus plus, j minus minus, my bad. C is going to be equal to q. We don't need to remove. We could remove. Actually, what we could do is instead do while q dot size is greater than 0. We could just do a q dot remove q dot size minus 1. That also works a little bit cleaner, I guess, or gets the point across what we're doing. So now we have the C, so this is what we need to complete it. So just like this, we're going to do a switch. This one only cares about these because this is all the things we can get. These can't be in our queue. So in this case, if we have this character, we are also going to have a subscore. So here's a score again. Call it subscore, sure. In this case, we have this is 1 point, and this will break. This will be our subscore. I think this is all we need to do. Is just do this. 2, 3, 4. Okay, 2, 3, 4. And so this will give us our scores. And then what we can go do is we can go add this to scores, add subscore, and then we need to do the very end here. This should be a long, just to play safe. We need to go ahead and do subscore. Oh, it's just scores, right? Scores, sorts, and it's gonna be long compared to. And then we go ahead and do scores dot get scores dot size divided by 2, because again it's gonna be odd numbers, so we can just go ahead and just divide by 2, and we should be golden, because that'll give us that middle number. 34 seems not correct. The completion string characters by character starting with a total of 0, then for each character multiply the score by 5. Oh, multiply by total score by 5, then increase the total number by the point given. Okay, so we are currently wrong. Equals this times 5 plus this number. My bad. That definitely does not work. Alright, let's just give this a YOLO here. Let's see if this is right. Hey! Top 1,000. I don't think... I actually did really well for today, for myself, but I didn't get... That's by far the best. But still not quite top 100. That's kind of insane, but... Anyways, I'm doing this in Java, so I don't expect to hit the top 100. If I do, that's kind of impressive for me. But anyways, day 10, nice and quick and easy for me, nothing too bad. Let me again clean up the code just to make sure it's actually looking good. I think it's actually pretty well, but let me go through it again just to make sure, clean it up, and then I'll come back and explain how I got to my solution. Okay, not a lot for me to clean up today. Honestly, it was pretty good. The only thing that really of note it did was I changed or removed the subscore. I just made a score. I just kind of reused that score variable here just because I could. Then I broke out this multiplication here because all of these do the multiplication, so there's no sense to do it all there. It's just kind of cleaning up. I don't know. It's not really needed. Honestly, I could get more fancy with how I did some of this stuff to make it even more generic, but it's just that it's kind of excessive for doing this and kind of using to teach and whatnot. So left it like it is, but at any rate, let's get to solving talking about how I solved the problem. So first off, the TLDR, the problem for today is that we are given a string of inputs here, each line having some sort of opening and closing bracket system of whatnot. So there's an opening and there's a closing version of each of the characters. And the first part is asking us in those which lines are first invalid in the fact that they close before they have more closing than opening characters, or the closing character is wrong for the given opening character it corresponds to. And then from those, what is the score of that, given the scores on this little table here of what each one corresponds to. But at any rate, to do that, because these opening and closings are happening to where the most recent opening is kind of paired with the now closing one, or the closing is then paired with the most recent opening, kind of whatnot. The way you do this is, or an easy way to do this is just use a queue. Java doesn't really have queues per se. Usually just use lists because it's just easier. I mean, there are built-in queues I could use, but lists are just a little easier just to use in general. But we go through all of our inputs, and we go through then of every input line. We go through every character in that line. If the character is one of these 4 opening characters, we simply just go and add it to the queue, add it to the very end. And then if we get one of the 4 closing ones, we have to then pull off the first of the queue. So in this case, the highest value, the most recently added to our queue, pull off that value, and then check if it is equal to what the character is expecting as its opening character. But in this case, we care about if it's not equal, because if it's not equal, that means we have a invalid line. Is that the word I use? Is an invalid line? There's a corrupted line. Sorry. If they do not, or in this case, so the parenthesis, if we do not have a opening parenthesis, that means we have a corrupted line, which then triggers us to increase the score by whatever that value amount is. And then we flip this flag here, so that way we kind of clear out of this for loop that's going through all the characters, because we no longer care about this input line anymore, because we've incremented our score. And we do this check for all 4 of these. So the square brackets looking for the opening square bracket, closing curly brace looking for the opening curly brace. The greater than sign is looking for the less than sign. I might get those backwards, but at any rate, they're looking for the corresponding kind of opening version of it. And if we don't have the opening version, we have a corrupted line. That's what triggers this whole thing. And then one more thing is when we have that corrupted line, we also want to remove this from the input, because part 2 does not want these corrupted lines. Part 2 only wants the incomplete lines. So that's why we were removing it here in part 1. This is for part 2, it's not for part 1. But at any rate, at the very end, we then just output the score that we've gotten as determined by these increments here. And that is part 1. For part 2, now we have our input again, but however, this input is again edited from part 1 to remove all of the corrupted lines. So now we are left with only incomplete lines. That means lines that have a valid number of closing, or the valid closing for the opening. However, they might be missing some closing braces or closing characters in this case. So just like part 1, we start with, again, building up our queue. In this case, again, if we have any of the opening ones, we add to the queue. If we have any of the closing ones, we remove it from the queue, because we know this is a valid input. It's just incomplete. We don't have to do the whole checking from above, because again, we checked in part 1 that all of the opening ones did correspond with the closing ones. So we don't have to do that check again here. We can kind of assume that it's all valid. And then what we do is when we get to the end here, we use a score again. And this time we are just going through the queue and pulling everything off, because everything that's in the queue right now has no corresponding closing tag or closing character. So because of that, we can simply just go through. If it is the opening parenthesis, we can say, all right, increase the score by 1. Again, these numbers are just pulled from the question here. It's an arbitrary point system. That's where these are coming from. In the case of the parenthesis here, we have an opening parenthesis. Well, that means we are missing a closing parenthesis, so we go and add 1 to the score. The score is also multiplied by 5. If you read the problem, you understand this. That's why this is here. But again, if we have a opening square bracket, that means we're missing a closing square bracket. Add to opening curly brace means we're missing a closing curly brace plus 3, and then so forth for the less than greater than symbols. And then at the very end, we also add the score for this line to our scores, because the answer is looking for the middle score value, and this is done by then just sorting the scores at the very end and then pulling out the middle one, which again, because we know it's odd, what we can do is you can just take the size of it, divide it by 2, and because of integer math, that'll actually give us that middle one because of how it rounds down. But yeah, there we go. Day 10 in the books. Not too bad, not too shabby. Hope you guys enjoyed. And again, for tomorrow, for day 11, I probably will not be doing it at midnight on, I guess, Saturday, Friday nights. I will not be doing it then. I will probably actually doing it live on my stream. So if you care, come join me on my stream on Saturday, twitch.tv/TrickDev. I will be attempting to stream there. That's my current plan, is to do the Advent Code challenge during it, edit the video, put it up, and then continue on with whatever else it's going to do. So that's all I got for you guys today. Hope you guys enjoyed. See you guys tomorrow. Peace out.